Okay, here we're going to talk about units 4 and units 5. Unit 4 was our rational expressions, so these were the ones that we had quite a few different rules for your asymptotes on. And then unit 5 was logs and exponentials, so I'll do probably, 2 or 3 of these and then one of each of your logs and exponentials here. This one is going to be from unit 4. This is a rational expression. One of the first things we talked about here was to go ahead and simplify this fraction if you can, which means you need to factor the top, the bottom, whenever you can. So in this one, that denominator is your difference of squares. Oopsies. And then the x plus 2's can cancel, and it is important that you remember that x minus 2 is going to stay on the bottom. So this is really the equation that we are going to work with. It's going to be much easier than dealing with this entire equation over here. What we have to remember, you can find your whole right now because you've simplified something out, and whatever you get when you set that factor equal to 0 gives you the x coordinate of your whole. So here, my x coordinate of my whole is -2, because if I do x plus 2 equals 0, I get -2. You, for your wholes, will have y values also. You are going to take your x value here and plug it into this function. So -2 minus 2 is -4. So the y value is just -1/4. Then we have to go through and find our asymptotes, was the other thing we did here after simplifying. And it was all based on your cases here. Your vertical asymptote always came from your denominator and setting it equal to 0. So I would have x equals 2 for a vertical. My horizontal is really where I was referring to the cases. And I will have some of each case here so that we can at least get through this part and talk about it. For your horizontal asymptote, you are looking at the degree of the top and the degree of the bottom. So here a 1 and a 2. Or if you're looking at your simplified, this is technically x to the 0 and a 1. And you're looking at which one's bigger. So here the bottom is bigger. If the bottom degree is larger, your asymptote will be at y equals 0. And I will, like I said, I'll go through one of each type here so that we can identify how you find those asymptotes. But if the degree on the bottom is bigger than the top, it's at 0. I'm going to draw in my asymptotes. I'm also going to fill in my whole just by drawing an open circle there. If your circle looks like it got closed, feel free to write whole next to it just so that you know I know. And then we're going to make our t-chart. As long as you have a vertical asymptote, I would center it on that. So I'm going to put 2 in the middle. And then I'm going to plug in 3 and 4 and 1 and 0. 2 won't work. If you plug it in, you get a 0 in the denominator. But again, it just centers it because I want some values over here and some values over here. And then I'm going to plug each of these into this function. So 1 over 0 minus 2 gives me -1/2. 1 over 1 minus 2 gives me 1 over -1, or just -1. 1 over 3 minus 2 just gives me 1. And 1 over 4 minus 2 gives me 1/2. So at 0, I'm at -1/2. 1 is at -1. 3 is at +1, and 4 is at 1/2. When we graphed these in class, we talked a lot about what was going to happen, and it's going to approach both asymptotes. So I'm just going to connect it so that it does. Then we're going to go ahead and do all of this characteristic chart. And this is where your domain can get kind of tricky. Your domain needs to be everything that x can be. And there were 2 values here x couldn't be because of my original denominator. It can't be 2 and it can't be -2. You can also get it just from looking at your vertical asymptote and the x coordinate in your whole. So I'm going to go from left to right with this. From -∞, I can plug in whatever I want. Oopsies, not 8. All the way up until this whole. So I'm going to have -∞ to -2 as my first section. Once I get past the whole, I can plug in anything from the whole to the asymptote. So I have one that is -2 to +2. And then once I get past the asymptote, I can plug in anything from that 2 to infinity. So what you will notice is both your whole and your vertical asymptote will show up in your domain. Your range is similar, but it's vertical. It's just going to include the y coordinate of the whole and the y coordinate of your asymptote. but you go bottom to top. So I get out every answer from negative infinity all the way up to my whole. So negative infinity to negative 1/4, but I can't get out that 1/4. But then I can get out everything between that negative 1/4 and my asymptote, which is at 0. And then I can get out everything above my asymptote, or 0 to infinity. These ones are the hardest ones for sure. So feel free, if you need to pause and listen back through that or ask me questions, please go for it. Moving on to the limits then, we just do the far left and the far right. So we're not going to worry about all those middle limits here in Algebra 2. So we're just going to do the far left and the far right. To the far left, my graph is approaching this asymptote. It's not going to go above it, so it is approaching 0. And to the far right, it's actually doing the exact same thing. If you look at this, it's going to approach that. These won't have maximums or minimums. These are always either, for the ones I will give you, increasing or decreasing, not doing both. This one, as you go from left to right, is decreasing. And so I'm going to write my entire domain on the decreasing line. For your x-intercepts, this is actually where my asymptote is, so I will not be able to have any. You would still solve it the same way as you do others by setting your equation equal to 0 and solving. My y-intercept I actually already did, if you look right here. And so my y-intercept is at 0, negative 1/2. What I did here for this next example is I just took the same exact equation and I flipped it over. So we could talk about what happens when the degree of the top is bigger than the bottom. You still start the same way by simplifying. And we will still have that whole at negative 2, like we did on the last problem. But now what's important to realize is when you're evaluating, it's going to look a little bit different because that x minus 2 is on top. When I plug in negative 2 there, negative 2 minus 2 is negative 4. So my whole is not at negative 2 1/4 like before, but negative 2, negative 4. Go ahead and put that there. For your vertical asymptote comes from anything still in your denominator, and there's nothing in here, so I'm not going to have one. For your horizontal asymptote, if the degree of the top is bigger than the degree of the bottom, you will also not have one. And so this one's not going to look like your typical rational function. It's going to look a little different. When I go ahead and make my t-chart, since I don't have an asymptote to center on, I'm going to instead center on my whole that I already found, just to give myself something to do. It around. And then I'm going to plug those in. Negative 4 minus 4 is negative 6. Negative 5, I got negative 3 and negative 2. You can also graph this just by recognizing that it's going to be a line. Either way is fine. So this is going to look a lot different, and that's okay. So let's talk through how this chart varies. There is no vertical asymptote. The only value I cannot plug into this is negative 2. So my domain is everything except negative 2. It's going to be much more straightforward than last time. Your range, the only thing y can't be is negative 4, because that's part of your whole. So it's going to be everything but negative 4. To the far left, my graph is going down because there's no asymptote to catch it. So it's going to be negative infinity. And the far right, same idea. It's going to be going up forever. I do not have a max or a min. This one is only going up. So it's going to be negative infinity to negative 2. Negative 2 to infinity. And then we're just looking at our graph. Our x-intercept, you can see right here, is at 2, 0. And my y-intercept is at 0, negative 2. Again, if you couldn't see your x-intercept, you would set it equal to 0. So I would do x minus 2 equals 0 and get it. If you couldn't see your y-intercept, you would just plug it in, but we already did that. The last case was when maybe you couldn't simplify. So in this example, you'll notice, first off, I can't simplify it. So there's nothing I'm going to do with that first, and I go straight to figuring out my asymptotes. My degree on top is the same as the degree on bottom, which means it is going to be your leading coefficients over each other. So what you're going to do is you're going to take the very first number that shows up, and so my horizontal asymptote here is that y equals 1 over 1. which is just at 1. It has to be that first number. It's really whatever's attached to your thing with the highest exponent. So if it's out of order, just be careful there. My vertical asymptote comes from setting my denominator equal to 0, so it's going to be at 2. My horizontal, or my holes, I don't have because I didn't simplify anything out. That's what it starts like if that's the case. I am going to go ahead and draw in my asymptotes to help make sure I'm plugging in these points correctly. I do have a vertical asymptote, so I'm going to put that in the middle, even though I can't actually plug it in, and I'm going to plug in things left and right. When your problem looks like this, you are going to plug into both the top and the bottom. So for example, for 1, I'm going to do 1 plus 2, so it's a 3 on top, over 1 minus 2, or negative 1, which gives me negative 3. For the 0, 0 plus 2 is 2, 0 minus 2 is negative 2, and so this will be a negative 1. For 3, 3 plus 2 is 5, over 3 minus 2 is 1, so it's just at 5. And with 4, 4 plus 2 is 6, over 4 minus 2, which is 2, so this is at 3. And I'm going to go ahead and plot these points at 1, we're at negative 3, 0, negative 1, 3 is up at 5, 4 is at 3. And again, we just draw that curve as we talked about with our parent function approaching both asymptotes. To do the characteristic chart, again, for your domain, look at your vertical asymptote in your hole, but we don't have a hole, so it's just everything except for 2. For your horizontal asymptote, same thing, everything except for 1. Remember, you can also do it visually from the graph. Think about left or right, what you can or can't plug in or get out as an answer vertically for your range. Your limits are your far left and your far right. To the far left, it's going to approach this asymptote, as well as to the right. And so both of these will equal 1, because that is where the asymptote is at. These are both decreasing. So I'll put my whole domain in decreasing. For x-intercept, I see that I will have one, so I do have to figure out what it is. And remember, for your x-intercept, always take your function and set it equal to 0. And with these, I think of cross-multiplying. So you'll do 1 times x plus 2 just gives you x plus 2. 0 times x minus 2 gives you 0. And when you solve that, you get negative 2. Y-intercept I did already plug in, so 0, negative 1 is my answer. Then when we got to Unit 5, we still had asymptotes, but the rules were significantly less complicated, but let's go through these. This one here is an exponential function. With exponential functions, you're allowed to plug in whatever you want. So what we tried to find was that center portion of our graph, which is always when you center it on h. So in this case, my h value is at 2, and I'm going to plug in things left and right of 2. So maybe 1 and 0, and 3 and 4. The other thing I always did right off the bat was identified my asymptote. Exponential functions have horizontal asymptotes, always at your k value. So this one will have a horizontal asymptote down here at negative 5. So I'll fill that in as well. These do not have vertical asymptotes or holes, just horizontal asymptotes. But then we're going to go ahead and plug this in. So when I plug 0 into that exponent, you're going to have 2 times 1/4 to the negative second, which is going to be 16. So 2 times 16 minus 5 gives you 27. And remember, these do grow quite quickly, so if you get some values off the chart, that's not a big deal. Here, when we plug in 1, it's going to be 1/4 to the negative first, which is 4, times 2 is 8, minus 5 is 3. When I do 2 minus 2 is 0, 1/4 to the 0 is just 1, 2 minus 5 then is negative 3. When I plug in 3, through 1/4 to the first is what this becomes, it's just 1/4, times 2 is a half, minus 5 is negative 4.5. And then 1/4 squared gives me 1 over 16. 2 over 16 minus 5 gives me negative 4.875. So it is approaching that asymptote like I expect. So if I graph the points I can, this one does drop very quickly because it was both a larger base, that 4, and that it is multiplied by 2. So that's why you'll notice it is getting big very quickly and small very quickly. Do make sure you show this steepness here and that it's not going to hit 0 for a while. Okay, for your domain, it's negative infinity to infinity because you can plug in anything you want. Your range, this graph has a floor. The lowest it'll get is really close to negative 5, and the highest it'll get is infinity. As we go to the left, my graph is shooting up because it is a decay function, so it's going up to the left and down to the right. So my function is going to infinity. If we go to the right, it's going down, but it's going to stop at that horizontal asymptote. So it's going to be f of x is approaching your 5 value. Here it doesn't turn around or do anything dramatic. This function is only decreasing. We need to find our x-intercept, though, and our y-intercept. So our y-intercept we actually already know, so I'll just plug it in because we plugged that into our chart already. For my x-intercept, we have to, as always, set it equal to 0. And I'm going to isolate this 1/4 to a power first. I'm going to add 5 and divide by 2, and you get 2.5 equals 1/4 to the x minus 2. And this is where we used logs to be able to solve for something in an exponent. If I rewrite this as a logarithm, it's going to be log base 1/4, because the base of your exponent is also going to be the base of your log, of 2.5 equals x minus 2. You're going to need change of base formula for that left-hand side. So you're doing log of 2.5 divided by log of 1/4, or you can just use 0.25 in your calculator. And that gives me negative 0.66096 equals x minus 2. And if you add 2 to that, you get 1.339 in my calculator. 1.3 is fine, comma 0. And again, if you look at your graph, it seems to make sense. Last one we're going to do here is your logarithms, which we also did in Unit 5. What we started talking about with logarithms is that you were going to have a vertical asymptote because there are things you can't plug into our logs. We have to make sure that whatever's inside my log is a positive non-zero number. So if we figure out what makes my log equal 0, which would be negative 4, that is going to be your asymptote. What that tells me is that for this left, I can plug in values, and I need to make sure that I'm only plugging in values really to the right of whatever that number is. So when we go to our chart, that asymptote goes at the top now because I am not going to have my graph show up over here. It's only going to be over here. And I'm going to plug in numbers to the right of it. This is going to become largely a test of being able to type this into your calculator, because you will have to do change of base formula. In that calculator, what you're really typing, you're doing 2 times, and then you need your change of base formula. So you're going to do log of whatever x plus 4 is, divided by log of 3, and then you're going to add 1, and you're going to have to do that all the way down the line. So I'm going to start typing these in. I suggest you also type them in so that you know if you're getting them right or not. Log of 3 divided by log of 3, which should give me 1. If you think back to your log properties, and then times 2 and plus 1 gives me 3. And log of 4 divided by log of 3, double it, and then add 1. So these should be the numbers that you're getting. Again, I primarily just followed that format that I showed you on the bottom. When you're plotting your decimals, just do your best. I know it won't be perfect. And when you draw it, think about that parent function that both approaches your asymptote and shoots upwards. Remember, these have the same general curve as your exponential functions, as they're just inverse functions of each other. For the domain, we could plug in anything to the right of -4 that we wanted. So it's from -4 to infinity, and it has to be a parentheses on that -4. Range is bottom to top, so it's -infinity to infinity because it goes down forever and up forever. On the left, it's going down forever, so it'll be -infinity. On the right, it's going up forever. I don't have a max or a min, and this one's only increasing, again, as you go left to right. Let's see, for my y-intercept, I do already know it. But it looks like I don't know my x-intercept, so I'm going to have to actually solve for that. As always, we're going to set the whole thing equal to 0. And we want to start by isolating our log. So if we -1 and divide by 2, we get -1/2. And similarly to how we did the last problems, we're now going to rewrite this, but instead of log form, we're going to write it in exponential form. 3 to the -1/2 equals x plus 4. Which, when you type this all in your calculator, you should get that x is -3.42. Again, always look at that graph. That seems to make sense. And so that's an answer I'm going to keep.